Hey, it's Mrs. Golding. We are on page 567 in your packet. 23 and 24 are the problems we're tackling. Again, we're writing and solving division equations. Here we have a piece of rope, and Blake is cutting it into fourths. Notice I'm using a tape diagram here to show that. So I have some length x, and I'm dividing it into 4 pieces, okay? And each piece is 16 inches long. So I represented that in my diagram. What is the total length of the entire rope? So I am going to write my equation based on my tape diagram. And again, the tape diagram is not something you have to do. It's just a visualization. If it helps, use it. So I have some value x, and I divide it by 4, and each piece is 16 inches, right? So it could look like this, or it could be some value divided by 16 inches gives me 4 pieces. Either of those is correct. Now, to make it quick and easy, I'm just going to extend my tape diagram, and I know 16 and 16 is 32, and 32 and 32 is 64. So that's 64 inches. Okay, good. Now, next one. This was a cool problem. That's an actual model, a picture of a model of a what was it called? An A-10 Thunderbolt. And those are the planes that flew over us last Saturday in Terre Haute. And I thought that was kind of interesting. They were used in Desert Storm, Kosovo, Enduring Freedom, Iraqi Freedom, mainly ground attacks on things like tanks and armored vehicles. And those are what flew over us. So I thought that was pretty cool. It's kind of a neat looking plane. But back to the problem, it says we've got a model of a plane that's 1/48th the size of the actual. The model plane is 28 inches long. How long is the actual plane? Okay, so I have, in this case, I'm going to use a ratio table, and I want to show you how this can be useful to you as a way of representing this. We know the model is, so for 1 inch in the model is 48 inches in the actual. Okay, so for like the model, 1 inch is really 48 inches, which is actually 4 feet, right? And we think in feet, so that's why I'm translating it, converting it. So I'm going to just kind of throw this out here. What would 4 inches be in the model? It'd be 4 times 48, right? We'd take 4 times 48. And that gives us 192, okay? 192 divided by 4 is 48, okay? So that's 48 feet. So 4 inches in the model is 192 inches actual, which is actually 48 feet, like 50 feet. You can imagine that, right? Now, it says we're talking about 28 inches. 28 inches in the model. I chose 4 strategically because 4 times 7 is 28, right? So if I take 192 times 7, right, 192 times 7, I'm going to get 4, 8, 9, 7. No, wait, something happened here. 63. 9 times 7 is 63. 7 plus, 13. 1334. 1,334 inches. I'm going to divide that by 4, and I get 336. I did this on another piece of paper just to save time, but I wanted to show you that to answer the question, what the book is asking you to do is to represent this, and you could model that by some length p divided by 48 is equal to 28. And you're going to end up taking 28 times 48, which is the same thing we got. P is equal to 1334 inches. But isn't it of greater value for you to know that that's 336 feet? I think you can visualize that a little bit better. So next time you see a A-10 Thunderbolt or something, you'll know how long it is.